Cape Canaveral Space Launch Complex 41, SLC-41. Space Launch Complex 41, SLC-41, sometimes referred to as SLC-41, is one of two launch sites at the Integrate Transfer Launch Complex, ITL, in Cape Canaveral Space Force Station, CCSFS, Florida. Originally built as Launch Complex 41, LC-41, it and the neighboring Space Launch Complex 40, SLC-40, were designed for the United States Air Force's, USAF's, Titan III rocket program, a modified Titan II with two optional solid rocket boosters, where it launched the Titan IIIC expendable launch system in the 1960s and the Titan IIIE, also known as the Titan III-Centaur, in the 1970s. In the 1990s, the Air Force and Martin Marietta upgraded the pad for use by the Titan III successor, the Titan IV heavy-lift space launch vehicle. During the early 2000s, SLC-41 pad underwent modifications by Lockheed Martin in order to support the launch operations of the Atlas V expendable launch system. It was later transferred to United Launch Alliance, ULA, a joint venture between Lockheed Martin and Boeing, who continues to use the pad today for launches of the Atlas V and its successor, Vulcan Centaur heavy-lift space launch vehicle. United Launch Alliance, LLC is an American launch service provider formed in December 2006 as a joint venture between Lockheed Martin Space and Boeing Defense, Space and Security. The company designs, assembles, sells and launches rockets. The company uses rocket engines, solid rocket boosters, and other components supplied by other companies. When founded, the company inherited the Atlas V rocket from Lockheed Martin and the Delta rocket family from Boeing. As of 2024, the Delta family has been retired and the Atlas V is in the process of being retired. ULA began development of the Vulcan Centaur rocket in 2014 as replacement for both the Atlas and Delta rocket families. The Vulcan Centaur completed its maiden flight on January 8, 2024. The primary customers of ULA are the Department of Defense, DoD, and NASA, but it also serves commercial clients. Launch Complex 41 was originally built as part of the Integrate Transfer Launch Complex, ITL, intended to launch Titan III rockets with solid rocket boosters in a method to enable a rapid launch rate. The ITL consisted of a Titan assembly facility at the Vertical Integration Building, VIB, demolished in 2006, a solid rocket boosters, SRB, attachment facility at the Solid Motor Assembly Building, SMAB, now used by SpaceX to process Falcon 9 payloads, and two pads at Launch Complex 40, LC-40, now SLC-40, and LC-41, all connected by the first rail line at the Cape. The facilities were completed in 1964, and the first launch from LC-41 was of a Titan IIIC rocket carrying 4 separate payloads on December 21, 1965. Throughout the remainder of the 1960s, LC-41 was used to launch 10 Titan IIIC, the entirety of them being military payloads such as Vela nuclear detection satellites and Lincoln experimental satellites, LES. The last Titan IIIC launch from LC-41 took place on May 23, 1969, launching Vela 5A-5B satellites OPS-6909 and OPS-6911, the later of which would detect a double flash in the southern Indian Ocean and instigate the Vela incident 10 years later. All remaining launches of the rocket were made from LC-40. In the early 1970s, LC-41 underwent a modification to launch the Titan IIIE, which replaced the transtage upper stage of the Titan IIIC with a Centaur stage. With the exception of its inaugural flight on February 11, 1974, every launch from the pad in this era contained a NASA payload. Those satellites were the two Helios probes, A and B, after launch renamed Helios 1 and Helios 2, sent to study the Sun, setting a proximity record only broken by the Parker Solar Probe, the two Viking probes, 1 and 2, sent to orbit and land on Mars, and the two Voyager spacecraft, 1 and 2, that flew by Jupiter, Saturn, Uranus, and Neptune. The Titan III facility at Complex 41 was deactivated in late 1977, following September's launch of Voyager 1. In 1986, the existing mobile service tower and umbilical tower at LC-41 were both stripped down to their main structural components as part of a renovation conducted by Martin Marietta, Titan manufacturer. This was done as part of their tear out and refurbish contracts, which modified and prepared the ITL for its new rocket configuration. LC-40 would get converted to use the civilian-based commercial Titan III expendable launch system, also known as CT-3 or CT-3, while LC-41 would be used for the military-focused Titan IV heavy-lift space launch vehicle. Additionally, Titan IV processing would go through the newly constructed solid motor assembly readiness facility, now used by ULA in the assembly of Vulcan Centaur, prior to launch. The maiden flight of the Titan IV occurred on June 14, 1989, carrying USA-39 for the United States Air Force. Similarly to most other Titan launches, all 10 launches of the Titan IV from LC-41 were classified military payloads, most going into geostationary transfer orbit. The Titan family of the 1980s and 1990s was marred by its price in the eyes of commercial customers, who instead opted to use cheaper launch vehicles like Delta II, designed and built by McDonnell Douglas, and Ariane 4, developed by the
Centre National d'Études Spatiales,
NIS, the French Space Agency, for the European Space Agency, ESA. Following Lockheed's merger with Martin Marietta in 1995, Lockheed Martin Corporation eventually decided to begin the process of retiring the Titan program in favor of their cheaper Atlas line. With any remaining Titan IV launches to be made from LC-40, the last Titan launch from Launch Complex 41 was on April 9, 1999, when a Titan IV-B launched the USA-142 Early Warning Satellite, EWS. The inertial upper stage, IUS, failed to separate, leaving the payload stranded in a useless GTO orbit. The inertial upper stage, IUS, originally designated the interim upper stage, was a two-stage, solid-fueled space launch system developed by Boeing for the United States Air Force beginning in 1976 for raising payloads from low Earth orbit to higher orbits or interplanetary trajectories following launch aboard a Titan 34D or Titan IV rocket as its upper stage, or from the payload bay of the Space Shuttle as a space tug. After the last Titan launch, LC-41 was renovated by Lockheed Martin and the U.S. Air Force to support the Atlas V as part of the Evolved Expendable Launch Vehicle, ELV, program, getting rechristened as SLC-41 in the process. The old launch tower and mobile service structure were demolished, while the new Vertical Integration Facility, VIF, was built for the assembly of the new launch vehicle. Additionally, the rail lines going towards the pad were renovated to support the assembly and transportation of the Atlas V and its mobile launcher platform for liftoff. SLC-41 was the site of the first-ever Atlas V launch on August 21, 2002, lifting Hot Bird 6, a Eutelsat geostationary communications spacecraft built around a Spacebus 3000B3 bus. Started in 1994 as the Evolved Expendable Launch Vehicle Launch System program, the initial program goal was to make government space launches more affordable and reliable, leading to the development of the Boeing Delta IV and Lockheed Martin Atlas V EELV families. These remained the primary launch vehicles for U.S. military satellites, and were later joined by the Falcon 9 developed by SpaceX. Over the years of the Atlas V era, SLC-41 was used to launch various noteworthy payloads for various agencies such as NASA and the U.S. Air Force. These include the Mars Reconnaissance Orbiter, MRO, on August 12, 2005, the New Horizons spacecraft to Pluto on January 19, 2006, the Juno mission to Jupiter on August 5, 2011, and two of the Mars rover missions, MSL, Mars Science Laboratory, on November 26, 2011, and Mars 2020 on July 30, 2020. Other notable payloads to be mentioned are various launches of the Boeing X-37B, also known as the Orbital Test Vehicle, OTV, for the Air Force throughout the 2010s, and a couple of Cygnus expendable uncrewed cargo spacecraft flights to the International Space Station in 2015 and 2016 following the failure of Cygnus Orb-3. In 2005, it was announced that a joint venture would form between Lockheed Martin and Boeing that would combine Atlas V operations at SLC-41 with Delta II and Delta IV operations at Space Launch Complex 17, SLC-17, and Space Launch Complex 37, SLC-37, respectively, following issues with profit abounding with competition between the two. This transfer in operation was made official in December 2006, with the formation of United Launch Alliance. The first launch from SLC-41 under ULA came on March 9, 2007 with a variety of Department of Defense payloads lifting off from an Atlas V. In 2011, the idea of rebuilding a launch tower at SLC-41 began to get proposed following Sierra Nevada Corporation, SNC, and Boeing's decisions to have the Atlas V launch their respective Dream Chaser and CST-100 Starliner spacecraft into orbit. Proposals turned into plans in 2014, following Boeing's winning of a contract as part of NASA's Commercial Crew Program, CCP, to launch astronauts to the International Space Station. Pad modifications at SLC-41 began in September 2015 to support human spaceflight to support Starliner, including the addition of a launch service tower to provide access to the capsule for pre-launch processing, crew access, and safety egress systems should the need to evacuate Starliner on the pad occur. The first launch utilizing the newly built launch tower came on December 20, 2019 with the launch of the Boeing Orbital Flight Test, OFT. This was followed up with the first crewed launch to be made from SLC-41, which occurred on June 5, 2024 with the Boeing Crew Flight Test 1, CFT-1, and carried astronauts Barry Wilmore and Sunita Williams into orbit. This was the first crewed launch from Cape Canaveral Space Force Station since Apollo 7 on October 11, 1968 and made SLC-41 the seventh pad in the Cape Canaveral area to launch astronauts into space. In chronological order, it joins Launch Complex 5, LC-5, Mercury Redstone 3. Launch Complex 14, LC-14, Mercury Atlas 6. Launch Complex 19, LC-19, Gemini 3. Launch Complex 34, LC-34, Apollo 7. Launch Complex 39A, LC-39A, Apollo 8. Launch Complex 39B, LC-39B, Apollo 10. Following the launch of CFT-1, it was also joined by Space Launch Complex 40, SpaceX Crew 9, in September 2024. During the late 2010s and the early 2020s, SLC-41, the Government Vertical Integration Facility, VIFG, and the SMARF, which was renamed to the Spaceflight Processing Operations Center, SPOC, in 2019 and then to the Amazon Vertical Integration Facility, VIFA, underwent minor modifications to support Vulcan Centaur, the successor to the Atlas V and Delta IV. This was in part due to the Atlas V using the Russian-built RD-180 as its first stage engine, which drew concern among Congress following the 2014 annexation of Crimea and the Russian invasion of Ukraine in 2022. As the Atlas V still had numerous pending launches, mainly for Starliner and Kuiper satellites as payloads, SLC-41's modifications were made to allow both rockets to take off from the pad, rather than a more traditional renovation like what was seen at Vandenberg Space Launch Complex 3 East, SLC-3E. The first Vulcan launch to be made from the pad occurred on January 8, 2024, carrying Peregrine Mission 1 to the Moon as part of NASA's Commercial Lunar Payload Services, CLPS.